Hi, in this picture, we will discuss about the adsorption of methane and carbon dioxide with the help of aspen adsorption. In the previous lecture, we have discussed about the flow sheet about the adsorption of methane and carbon dioxide using the aspen adsorption. This was feed, this was stream number 1, this was feed well, and this was bed B2. You can rename it, right click on it and rename block. So I am changing it to bed. Click on OK. This is bed. This is product well, this is product stream. So double click on feed and we have specified, click on it. So 62% was methane and 38% was carbon dioxide. The temperature of the feed was 290 Kelvin and it was entering to the adsorption column at 10 bar pressure. The molar flow rate was in kilomole per second. This was the product stream. Click on it, specify. It was pure methane and there was no carbon dioxide. Temperature and pressure was slightly decreased, 9.95 bar. This was the bed. We have specified the bed like momentum balance, the convection with estimated dispersion, organic equation. The kinetic model was the solid, lump resistance, linear and constant mass transfer coefficient. Isotherm was extended Langmuir and it was partial pressure dependent isotherm. The energy balance was non-isothermal with gas and solid conduction and there was no heat transfer from adsorbent to the surrounding. It was adiabatic. There was no reaction. We have specified the bed like the bed height, bed dia, intraparticle and interparticle voidage, the density, etc. The heat transfer coefficient, the specific surface area of adsorbent, all values were specified in the previous lecture. We have also plotted some graphs like breakthrough curves, like go to this one, this star, and here plot. So breakthrough curve, breakthrough curves for methane and carbon dioxide. So click on product, go to results, drag and drop the results of methane and carbon dioxide. Now click on this time axis, double click on time axis. The time window is, suppose I want simulation for 300 seconds. The grid interval, suppose the grid interval is 50 seconds and the time axis is from 0 to 300 seconds. Click on OK. First of all, go to initialization to initialize the bed. Click on OK. The run is completed. Click on OK. Go to dynamic mode and here go to the run up this button. So time now is 0 and it will pause at 300 seconds. Click on OK. Now this is dynamic mode. Click on run button. Click on OK. So this was the breakthrough curve. Here you can see this was the breakthrough curve. 50 second, 100 second, 150, 200, 250 and 300 second. This is the time axis and on the y-axis this was the mole fraction of methane and carbon dioxide in the product stream. So here you can see after 100 second the methane concentration is decreasing inside the bed and the carbon dioxide is increasing. So after 100 second the adsorption of methane will taking place. Methane is slightly decreases. It means that methane is adsorbing after 100 seconds inside the adsorption column. And after 100 seconds, the carbon dioxide is desorbing. It is removing from the bed. So more and more carbon dioxide will coming out in the product stream. Here you can see it is increasing and it is decreasing. So here methane is decreasing. It means that it is adsorbing after 100 seconds inside the adsorption column. There can be activated carbon, silica gel or some other adsorbent like zeolite or some other activated carbon or some other adsorbent which are using to adsorb the methane or carbon dioxide gases. Now you can also change the plot like right click on the graph this plot right click, go to the property, and here you can change like this one. If you want this line, and I want carbon dioxide in this line pattern, click on apply, and here you can see the line is this is slightly changed. Now you can also go to the, suppose this is the map axis, this is the x-axis, this is grid mesh, here this is mesh, vertical line and horizontal line, this is in the mesh form. If you don't need grid, so here click on apply, so it is, there is no grid. If you want line and marker, the marker size, etc., you can change it like 3 4. So I'm changing it to 4, and I also want mesh. Go to attribute, and here go to this line and go to this line. I want this line in red, suppose, this one in black, or you can change this to blue, this one to black. Okay, click on apply. Here you can see methane, the line is changing. Okay, you can also change the suppose this one. Here you can see, suppose I want this in this one, apply. So here you can see this was the breakthrough curve. This was the breakthrough curve. Now I will close this one, and I want to plot the loading curves of methane and carbon dioxide inside the adsorption column. So we will go to the initialization, click on OK, and go to this button, loading, methane and carbon dioxide loading inside the adsorption column. So this is loading. Go to bed, click on it, click on this one, configure, go to results. This is the bulk concentration solid loading. Here I will go to the solid loading. Here you can see the solid loading. Okay, okay, again run this one. Okay, okay, this is time, this is the y axis. Go to dynamic. Okay, this one is okay. Initialization. Okay, cancel this one. Okay, okay. Now here you can see we will initialize our problem. So go to view tool, and here you can go to the initialize button. Here window tools. Okay, you can see here view file. Okay, I want to initialize the bed, so I will close this one, close this one, close this one, click on initialize, click on yes. Okay, now close this one, and again go to plot, go to loading. The type is already exist, so I will change loading up CO2 and carbon dioxide. Okay, go to bed, double click on it, click on configuration, close this one. This is loading. Go to results, and here bulk concentration. Okay, this is the mole fraction, solid loading. Okay, initialization, and click on OK. Now I want the loading up methane, carbon dioxide inside the adsorption column. So click and drag and drop methane, methane, drag and drop the carbon dioxide at node number 1. This is node 1, node 2, node 3, node 4. So suppose at node number 5 carbon dioxide, at node number 10 the carbon dioxide, I want the carbon dioxide at node 10 is node number 9, I think. Okay, carbon dioxide at node number 9, at node number 15 suppose the carbon dioxide loading at node 15, and at node number 20 solid loading a carbon dioxide at 20. Okay, but now double click on time axis. I want a simulation for 300 seconds. Grid interval is, suppose I want it 50 and the time window will be 300. You can change according to your problem. Click on OK. Okay, now okay, go to dynamic mode. Here go to this button and check. It is the time now is 0 and it will pause it. Simulation will pause at 300 seconds. Okay, click on OK. Now click on run button. Click on OK. Close this one, and here you can see methane. First methane is decreasing. At node number 1 methane is decreasing. It means that it is absorbing. And here you can see the carbon dioxide loading is increasing. The methane is decreasing. Here you can see the methane is decreasing. At the first node it is decreasing, but the carbon dioxide is increasing. The carbon dioxide is loading. The carbon dioxide is absorbing, but methane is dissolving at node number 1. At the beginning of the adsorption column, methane is decreasing and carbon dioxide is adsorbing. The carbon dioxide is attaching to the adsorbent particle inside the adsorption column. Here you can see at node number 20, it will take long time. It will take long time. For example, it will take about 200 seconds to reach the equilibrium. Here you can see at node number 15, it take about 150 seconds to reach the equilibrium, to reach the carbon dioxide at equilibrium point. Here you can see at node number 9, the carbon dioxide will take 100 seconds to reach equilibrium inside the adsorption column. Similarly, at node number 5, you can see the carbon dioxide will take about 50 seconds or about 100 seconds, about 80 seconds or 70 seconds to reach the equilibrium. Here you can see, you can check from this line. It is not changing, so it slightly increases. You can also increase the time to reach the equilibrium. Similarly, methane, and this is the carbon dioxide. So here you can see after 100 seconds, the carbon dioxide will reach the equilibrium inside the adsorption column. So this is the loading of methane and carbon dioxide. So suppose I want, if you want to increase the time, so you can increase the time, like I want at 100 second. The grid interval is suppose 100 second, and the time window is suppose 1000 second. Click on OK, and here uh, the simulation now, the time now is 300. Here you can see time now is 300. This is 300 time, and the graph is formed 300 second. So up to 300 second we have made the plots, but now I want it at 1000 second. So we will change the window from 1 to 1000 second. So 1000, I will pause it 1000 second. Okay, and time now is 300 is okay. Click on OK and click on run button. So it start from 300, it is 700, 800, 900 and 1000. So here you can see it is still some point reached to the equilibrium, but still some points are not reached to the equilibrium. So I want further, I want at 2000 second. Suppose at 2000 second, 2000 second, and this is Time window is 2000. Click on OK. Time now is 1000. OK. Now click on run. So here you will see. So here you can see. Okay. So okay. Now close this one. Click on this red button. It will close. Okay. Click on this one. Okay. Now it is increased from 2000 seconds. So click on the time axis and change it to 2000. 2000 and from 0. Time is time grade interval is 100 second is okay. The time window is 200,000. Okay. So now here you can see it is reached to complete equilibrium. Here you can see at 2000 second the carbon dioxide is reached to the equilibrium inside the adsorption column, and at 300 second or 200 second you can see the methane is reached to equilibrium inside the adsorption column. Now, if you want the loading along the height of the adsorption column, so you can also plot it. Like first of all, I will go to the initialization. Click on OK, and here change it. Okay, go to the dynamic mode. The time now is 0, and I want my simulation for 2000 second. Okay, now go to this arrow, click on profile plot, and click on loading along the height. So it is already exist. The loading is already exist in the aspen absorption. So CO2 and methane loading. Click on OK. CO2 and methane loading. Okay, maximize this one. Right click, go to profile variable. Minimize this one. Okay, point variable. Click on point variable. Click on point. So all variable will appear in this window, in this side. You can see. So click on this one. This is profile and this is profile variable. So this is length or height of the adsorption column. Length. And what is the variable? So it will be the height of the bed. So you can check here the bed the axial distance. Here you can see, drag and drop this one, remove the one because we want the simulation for all node, not for node number one. So this star shows that the simulation will be for whole length or whole for the whole height of the adsorption column. So that will be on the x-axis. Click on x-axis. So the length is on the x-axis. This will be on the x-axis of the plot on this one, this side. Click on this one and now go to the loading side. So the carbon dioxide loading, suppose carbon dioxide loading, click on this one. Okay, bulk concentration to loading side, gas phase, heat of absorption. gas pugacity. Here you can see various variables. There are various. You can also find in this place. But here I'm searching in this one. So mass transfer rate. These are variable point. The density. Gas temperature. Solid temperature. Solid loading. Here you can see. So the solid loading of methane. Suppose the solid loading of methane for the whole column. Replace one with star and plot. Click on plot. So what is it will plot the CO2 loading. The CO2 load. This is methane loading. So methane NH4 loading. Loading. Remove this one and plot methane loading. Now CO2 loading. CO2 loading. This one. This is the CO2. Replace this one with star. One with star. Okay. Okay. And plot CO2 loading. Click on apply. Close this one and here maximize this one. So here you can see this is the length. The length. So at the whole length you can see methane and this is the carbon dioxide. So the methane and carbon dioxide loading slightly decreasing. It is slightly decreasing at 0.1 length, at 0.1 meter, it is slightly decreases. And here you can see 0.0026276 is the methane is the carbon dioxide loading at the last point. And here you can see the methane loading is slightly increase 0.00125 at the last point of the adsorption column. So the length, this is the length. The length you can change it. The length is in meter. So click on OK. This is the height of the column. This is height of the column. So you learned that how can we make the loading graphs and the loading graphs inside the aspen adsorption. Thank you very much for your attention.